Eliminating. Eliminating what? No. Letters. Eliminate a variable, right? We're trying to eliminate one variable so that we only have one variable to work with. So if we're going to do elimination, what does that mean for like a problem like this? What are we trying to do? Figure out what x and y are, because that's going to be your answer. How do you do that? Isolate would be substitution, right? Yes, so we want either the x's or the y's to be opposites. Remember that? So right now you have 2x and you have 1x. Are those opposites? No. Okay, now look here. You have 1y and you have negative 5y. Are those opposites? No. So what we have to do is then, if they're not opposites as they sit, then you have to make them opposites. How could I make either my x's or my y's opposites right now? By what? You can multiply the top by, I would do negative 2 to make them opposites, or positive 5. Okay, what do you want to do? Negative 2 or positive 5? 5? Okay. So here's how we set this up then. This whole thing, we are going to multiply by 5. What that becomes, and I'm going to write it down below here, 5x, then it's plus 5y, and this is the one that everyone forgets. That 5 has to get multiplied by the 4 also. Okay? So now you have this. We changed this one, so we're not using that top one anymore. Eventually you might use it again, but we're not going to use it right now. Okay? We're just going to use these bottom two and eliminate. How do I eliminate? What's my first step going to be? Add. If these are opposites, then we're going to add these together. So this is going to be 2x plus 5x is 7x. Negative 5y plus 5y is 0. So that goes away. Bring your equal sign down. 15 plus 20 is 35. So now you have 7x equals 35. What do? Divide. So we're going to divide by 7, divide by 7. So x is 5. Are we done? No. What I was multiplying by. We just wanted to make these opposites. Right now it's a negative 5y and a positive y, so that's like 1y. So if I multiply that by 5, then it's a 5y and a negative 5y, and then they eliminate each other when we add them together. So you could do that with your x's or you can do it with your y's. If you're going to do it with x's, we would have had to multiply by negative 2 so that this 2x would go away. Okay? Either one, but don't do both, but one or the other. That's what I was just explaining to him. You want to make them opposites, right? So if you take this as your starting setup, this is a negative 5 right now. This is a positive 1 right now. If those two numbers have to be opposites of each other, if this is a negative 5, I got to make this a positive 5. Well, the way I make 1y 5y is I multiply it by 5. So then you have to multiply everything by 5 so it doesn't change your final answer. Does that make sense? Okay, so we get to x equals 5. What else do you have to do?
You have to plug in the x equals 5.
Yes, so I would go back to this first equation. X plus y equals 4. So drop in the 5. 5 plus y equals 4. And then just solve for y. Y equals negative 1. So your answer can either be written as the point 5 negative 1, or you can just leave it x equals 5, y equals negative 1. I'm fine with that too. But just notice, how many solutions is this? It's one. It's 1 point, right? So yes, there's two numbers. That is one solution. We'll talk about that in just a minute. Khalees. Okay. If you remember, let me know. Okay, look at this one. Very similar type of problem. And again, we want to do elimination. Khalees.
So we get the same answer if we answer the same question.
If you plugged it into what?
The second.
Yes, yep. Yeah, you can plug it into either one.
But it would just take longer.
It would take longer, yeah, but you could. You good? What do you do on this one? Lincoln.
Find the GCF of one of them.
There's no GCF with
Or
the four
greatest, like the no, not like
of both of them, you're saying.
the.
Yes, you're
I
finding,
don't know what it's called.
yeah, finding a multiple that you could, something you could multiply by to get them to be the same coefficient or opposite coefficients is really the best way to do it. Because right now you can't multiply 4 by something here to get 5, and you can't multiply 5 to get 4, and you can't multiply 3 to get 4, and you can't multiply 4 to get 3. Okay? So you're not going to be able to just multiply one equation. So if you can't multiply one equation, then you have to multiply both equations. Micah. Yes, except for then they're not opposites. So I would do 4 and -3, or -4 and +3, because you want them to be opposites of each other. So if I take this top one and I multiply by 4 to make this a 12, then I would multiply the bottom one by what? -3 to make it a -12y. Okay? You could have also done 5 and -4 for your x's. Okay, so it's just a matter of which one do you think makes the most sense to you. So this is 4 times 4x, so 16x. 4 times 3y is 12y. And then 4 times -1 is -4. Okay, then we go to the bottom one. This is a -15x. This is a -12y. And a -3. Okay, so we're just going to ignore those top two equations now, because now we have this new set of equations. What do you do with them? You add them. They're opposites, so you add them, because we want the one to be 0. This is 0 when you add them together. So add everything. 16x plus a -15 is 1x, or you can just write it as x. Bring your equal sign down. -4 plus -3 is -7. So x is -7. You with me on that? Okay. So I just am looking for, if these are my two numbers, 3y and 4y, and I want to find some multiple of those numbers. The least common multiple. Is that the word you were looking for, maybe, Lincoln? You want your least common multiple? You're trying to multiply by something to get them both to be equal numbers, but opposite equal numbers. So if I multiply a 3 by 4, that'll get me 12. If I multiply that 4 on bottom by a -3, that'll get me -12. I want 12 and -12 because they'll eliminate each other. So you're just choosing numbers that would get you there. Those aren't your only options. You have an infinite number of options, but you would get really huge numbers if you go bigger than that. Okay, are we done? No, what do you got to do? Plug it in to one of them, and it doesn't matter which one. So you can go 4 times, I'm plugging into this one. You can actually plug it into any of these 4 now. I don't usually do the new ones because they're bigger. So 4 times -7 plus 3y equals -1. So this is -28 plus 3y equals -1. Add 28 to both sides. So 3y equals 27. And then divide by 3. So y is 9. Okay? That means your answer is the point -7, 9. Again, if you leave it like this, I'm fine with that. but just understand that this is one solution. Yes, it's two numbers, but it is one answer, okay? Yes. What? Okay. Questions on elimination? It was a long time ago, huh? January. This is January.
Do I have to make it a point?
No. All right, look at number 3. This one's substitution. And for substitution, we are substituting. So I probably talked to you about basketball at the time because I feel like that's where I usually go. If you take a point guard out of the game, what do you want to put into the game? Another point guard. You need a ball handler, okay? So whatever you take out, put something of equal value back in, okay? If you take the quarterback out, probably going to want to put a quarterback in so that someone can throw the ball. So if we know what y equals, if there is something already isolated, you take that isolated thing and you put it where? In for y in the other equation. So this is going to go here with parentheses, lots and lots of parentheses. So you're going to say 2x minus 3 times what y equals 4. So you just take this 2x plus 4 and you drop it in for y because we know that's what y equals. Now here's where a lot of mistakes happen. What's your next step? Distribute. What are you distributing? A -3. Okay, be really careful with that. 2x minus 6x minus 12 equals 4. Okay, and then simplify that. So 2x minus 6x is a -4x. And then you can add 12. So -4x equals 16. And divide by -4. So x is a -4. Are we done? What do you gotta do? Plug it back in. I would say the best place to plug it in is right here because it's already isolated the y. So y equals 2 times -4 plus 4. So that's -8 plus 4. So y is also a -4. So if you want to write it as a point, it's the point -4, -4. How many answers is that? 1. That is one answer. It is the point -4, -4. You don't have to. You can leave them separate. I just want you to understand that's one solution. Here's why I want you to understand this. I would write this on your note card. There's a question just like it. How many solutions does a system have? So if you get 3 equals 11, how many answers is that? None. No solution. There is no solution if you come up with 3 equals 11 as your final answer. What if your answer is x equals 2, y equals -4? How many solutions is that? That is one solution, right? An x and a y, a point. That is one point. That's the one that a lot of you are going to get wrong on your final if you're not paying attention because it looks like 2. And it's really tempting to say this is 2 solutions, but it is a point, 1 point, okay? How many solutions if you get -4 equals -4? Infinite. Infinitely many or infinite solutions. Because no matter what value you plug in for x, you will always get that. Okay? Okay, we're going to stop.